Welcome back. On this segment, what I want to do is pick up from where we left off with Joe Duran, Walter Schruert, and Edward Deming, and start off with Philip Crosby. So Philip Crosby is a name that's fairly well known in the quality space. Some interesting background. So he had worked for a company called the Martin Company. At the time, it was called Martin, became Martin Marionette. You might know them today as Lockheed Martin. So a very large military contractor for the U.S. And in fact, Crosby's a lot of the beginning of his quality career and really kind of making a name for himself, it was at his time at Martin, although he later went on to ITT and then opened up his own consulting and education organization. When he worked for Martin, he was part of the Pershing missile program. So Pershing missile was an intermediary range ballistic missile program. It was designed to replace the Redstone, which was the previous missile that they had. Interesting problems with this kind of cutting edge technology. And that's that when you have issues with the systems operating, there's a tendency for them to fail spectacularly. So you probably have seen maybe YouTube footage before of missile launches where they get partway up in the air and they blow up, or they go up a little bit and they fall down. And there's lots of footage of the early V2 rocket program where you can see all kinds of failures that they had. That's kind of an artifact of that kind of a system. There's cutting edge. There's an awful lot of technology involved, and you don't really get a chance to test it per se, and then make changes to that existing piece, right? So if you launch it and it doesn't work, it tends to fail spectacularly, and you're back to making a new one. And so this was a fairly significant challenge that they had. And the way that Crosby approached handling some of these quality problems really set the stage for an awful lot of the more popularized aspects of quality, certainly in a North American dimension. Although Deming and Duran had worked on a lot of this stuff, and you'll find that all of these people, they're singing the same song, they're just using different words and different expressions for the same things. Crosby found a way to really make this a lot more real for a North American manufacturing audience. So here's some key pieces to take away from Philip Crosby. So the first one is quality means conformance to requirements, not goodliness. And this fits into as I mentioned in the previous segment, one of the challenges with taking the quality message to North American audiences was that they had a tendency to think that it was a philosophical and intellectual and ideological kind of issue as opposed to a practical one. And he was like, no, I mean, your quality dimensions are set by your customer, and it's those requirements that drive it, right? Certain customers will have different levels than others, and it's achieving the levels that you need for that particular customer is what you're after. It's not like a kind of an arbitrary thing. And the way that you achieve quality is by prevention, right? Not appraisal. And appraisal is basically inspection. And I mentioned in the previous segment, the first steps most companies take down the quality road are inspecting. And as I said, inspection plays a role, but inspection doesn't fix anything. Inspection tells you have a problem. It may tell you the degree of the problem. It may tell you where. It may tell you when. It may tell you a bunch of different things about it. It does nothing to change the fact that you've had a problem. One of the examples, if you listen to any of the talks that Edward Deming has done, one of them is that he likens it to a thermometer. So a blistering hot day and you look outside and the thermometer says it's 104 degrees Fahrenheit, right? You didn't need a thermometer to tell you that it was blistering hot out, right? You already knew that. You didn't need that extra piece. So although appraisal plays a role, what you have to do is prevent it, as opposed to trying to catch it and sort it out, because that was the first step, really, is that you'd make a bunch of stuff, you'd inspect it, and you'd sort out the good ones. Well, you have 100% of the costs in the bad ones. And then that cost ends up getting stuck on top of the good ones. That makes your products more expensive, that makes you use more materials to make the same amount that comes out the other end. It's a very inefficient process. Other piece that he's known for is the concept of what he did, what they called zero defect days. So again, put your mindset in, in the 1950s, and the folks at Martin that were working on the Persian missile program. And as I said, a lot of the first steps in the quality road are about inspection. So people kind of think, well, I'll do what I can, but like if there's a problem, Joe in quality control will catch it, right? Somebody will find it down the road, inspect it. And what Crosby did was get people to focus on, no, like the acceptable level of defects is none, right? So it's not okay to make some mistakes and let somebody catch it down the road. You're trying to prevent making any mistakes. So they did these days where they focused on days that there would be absolutely no defects in the processes and the subsystems that they were producing. And he created a whole event around it. It was really focused. And it was so much about changing the mindset of the workers away from, I'll do what I'm doing, and if there's an issue, someone will catch an inspection, to I need to pay more attention to the things that I'm doing so that I prevent those issues from happening in the first place. And that was a huge step forward in changing the mindset. Another part that you'll find in Crosby's work is this concept of, it's often referred to as cost of quality. It's a concept that there's roots in Durand's work, there's roots in Feigenbaum that we'll talk about in a couple of minutes, but Crosby is probably really well associated with certainly North America, because in 1979, he published his first book called Quality is Free. And the basic precept of the book was that in this concept of cost of quality, and we'll spend more time on this later on in the semester, basically all of your costs add together to a total cost of quality. So you have prevention, appraisal, and then you have failure costs. Those all together give you a total cost of quality. When you reduce your failures through activities that you do in prevention and appraisal, what happens is you reduce your total cost of quality. So for organizations that think they can't afford to spend more time and attention on how they produce, or building jigs that will make them more accurate, or any of these other investments that are kind of on the prevention side, his point is you're already spending that money today, but you're spending it in failures. So why not redirect the money in failures towards prevention and appraisal activities, and you can lower your overall cost of quality. And this quality is measured by the price of non-conformance. So what's your cost of failure, right? And there's both internal failure and there's external failure. And we'll spend a lot more detail into this as we get along in the course, but it's one of the very significant pieces of his work. Like I think everybody else in quality, he has his 14 steps. As Deming did, as Durand did, as most of them do. But you'll see it's a reflection of the same kind of information and the same kind of concepts. They're just different ways to come at the same problems. Now, Feigenbaum, another name that comes up in this period of time, also contributed to the whole concept of total quality management. So he proposed a theory of total quality control, talked about it being company-wide process, which again, like I said, this was something that you see in Joe Durand talking about it going all the way through. Quality is defined by the customer, right? Which you see reflections of that in Crosby about it's driven by specifications. Quality and cost is a sum, right? So, and this is this concept of cost of quality, and that the investments and the costs involved in prevention activities and appraisal activities added together with your failure costs kind of give you an overall cost of quality. And in fact, the end result of a cost of quality system is that you try to make the appropriate prevention and appraisal investments so that you lower your failure costs, but in the process, you lower your total cost of quality. And the goal is to get as close to zero as possible. I mean, you'll never get to zero, but that's the goal that you're trying to go for. Kuru Ishikawa. So that's the first Japanese name that's on the list, although we talked about before that a lot of the roots of the modern quality revolution took place in Japan. So Kuru worked for Kawasaki. And Carew is known for a number of things, but probably two of them more than anything else. So one of them is this concept of quality circles, right? He's often referred to as the father of quality circles. So the way Japanese manufacturers, post-war Japanese manufacturers approach operating their business is different than a lot of North American or Western European businesses. There are some cultural things that are different about them, and we'll talk about that in upcoming lectures. But one of the things that he popularized were that the workers themselves, and these are groups of people that are working in various areas in the manufacturing organization, would work together in these small groups, being responsible for not only the work that they did in the output, but for identifying and solving their own problems as they came up. So as opposed to, them being a mechanical instrument only, if you will, like I'm the guy that puts the steering wheels in and this is how I do it. I may do the steering wheels and somebody else does the seats and somebody else does something else, but collectively we're really invested in the things that we're doing and the outputs that we're creating. And when we see issues or opportunities to do things better, we as a group kind of take it on ourselves to deal with and understand and make changes to these processes. So it's this whole quality circle concept. And one of the things that comes out of quality circles, and we'll spend a bunch of time in your first assignment actually has to deal with this, is the 7 quality tools, right? So Carew is attributed with this pulling together of the 7 quality tools. And these are the things that the quality circles would use to understand their environment, to understand challenges, to identify potential root causes, things like that. And in fact, most of the 7 tools, or in fact 6 of the 7 tools, originated with other people in another time periods, right? So Pareto goes back to Vilfredo Pareto in Italy. Control charts is a Shruert thing. So there's a number of them in there. He did develop his own. That's called a cause and effect, or sometimes called a fishbone diagram, because of the shape of the diagram kind of looks like a fish's skeletal structure. It's also sometimes known as an Ishikawa because of where it comes from. And an Ishikawa is designed to help you figure out what might be causing a particular issue. So the head of the fish is where the problem goes in, and then down the various parts of the skeletal structure, you're basically looking at what might be causing, this particular issue in a bunch of places. And it helps you uncover and get to root cause, which is ultimately one of the things that they're driving at. And you'll see that's the last point here on the slides, is removing root cause, not symptoms. Symptoms are a little easier to find, but removing the root cause is far more meaningful. Just a tiny bit on Taguchi here. So Taguchi is probably best known for the Taguchi loss function. Taguchi loss function really looks at the impact to society by poor quality. When something doesn't work as it's supposed to, or there's a failure, or it requires additional maintenance or repair cost, or a variety of other things, there's loss to the organization in those costs, because often there's warranty costs and things like that, but there's loss to society from this not doing what it was supposed to do. And in some cases, the loss can be quite significant, right? So if you think of an airliner that doesn't perform properly and crashes and kills everybody on board, right? That's a pretty significant issue. To some degree, in all of this COVID-19 stuff going on, if truly the source of the virus was originally coming from the jump from animal to human in one of these wet markets in China, that operation of that wet market in China has caused a tremendous loss to society all over the world because of some quality issues and how that was managed, if that in fact is the root cause of it. So it does have a very significant impact to society overall. Now, I'll spend just a tiny bit talking about the Shruert cycle, which is this PlanDoCheckAct. And then I don't know if you noticed, but one of the things that Deming did is made a slight alteration, and he changed it to PlanDoStudyAct. And what that was really meant to do is, the Check Act was basically, right, we plan, we're doing something, we're checking to see if we're getting the result. If we're not, we're going to make an alteration of what we're doing to try to fix whatever the problem is. Well, that check tends to be a short-term reactive approach to whatever's happened. Deming looked at it and said, although you may be able to potentially resolve that one individual issue with a smaller reactive thing, one of the challenges with reactions is that the options that you have for what you do tend to be fairly limited, and they tend to be suboptimal. So he looked at it as an opportunity for a little more detailed study. So don't just react to what's happened, get underneath of why. Why did that happen? Maybe we haven't seen it before, so why did we see it now, right? Are there distinctions and changes of something that happened? Was there something that happened or a change in the environment just before we saw this thing come up? Like basically better understanding, because it lets you get ahead of what might have the actual root of what might have been causing, because you'll find often that root cause can lie dormant for quite a while, and then there's a certain set of circumstances that causes a problem to pop out. But the truth is, in a lot of cases, if you were paying more attention to what you were doing, you would have reasonably known that this was kind of an accident waiting to happen. And I think when we get into cost equality more and we look at some of the examples, you'll see that in a lot of cases, root cause for most of these issues pre-existed before the problem came up, and often pre-existed for quite a while. And there was a specific set of circumstances that caused it to pop out. But truthfully, had the organizations been paying more time and attention to what they were doing, they would have prevented the issue from coming up in the first place. So it's just an overview of the short cycle here. We talked about this piece. All of these people that we're talking about are all part of what we refer to as the total quality management revolution, or circle, or philosophies. And some key pieces of that are things like customer focused. And later we'll talk about different types of customers, because it's more than just the direct transactional customer. Requires total employee involvement. I mean, the whole zero defect day thing concept from Crosby was about getting the people that were doing the actual work to understand the implications of what they did and the ramifications of mistakes that they potentially made. Deming is known for being quoted as saying that, we pay people to make mistakes, because companies do. They might not mean to, but they're ending up doing it. Another aspect of TQM is process centered. Right? So you have a process that you do things. You don't have different people doing the same thing different ways. You come up with a process, you're consistent with that process, and then as you can, you make alterations to that process to make it better, right? To make the outputs better, to make the amount of resources used to produce something less, things like that. You'll find all TQM stuff is an integrated system, right? Where you have inputs and outputs and processes and all of these things tied together. It's both strategic and systematic in its approach. It's focused on this continual improvement. And I think a good way to look at it is like every day, it's like, how do we do what we're doing better tomorrow than we did today? And you're forever looking at how do you make these improvements. And fairly small changes over a period of time can lead to really, really significant changes in the overall output. So this continual improvement is a really big piece of it. Fact-based decision making, which is key. It's not about what you think. It's about what the data tells you. Although your instincts may be good, and the instincts may help you direct towards where you should be looking and what kind of information you should be looking at, they're instincts only. What you see is not the same thing as what other people see, and it may not be a reflection of the reality of that situation. You really need to use the facts to tell you what's going on, and use that to drive your decision-making process. And in fact, the whole 7 quality tool space is all about using data and facts to help drive decision-making and exploration. And then fundamentally, communications is such an enormous piece of TQM, and we'll spend quite a bit of time towards the end of the course talking about the role of communication. I won't spend a ton of time on Six Sigma, because you have a whole separate course on Six Sigma, right? But Six Sigma, Foundations in Motorola, came about honestly because, so Motorola had been a leader in the telecommunications space. They were starting to lose out to Japanese and Swedish and other manufacturers. And Six Sigma was their way to stay in business. So essentially, they at the time when they came up with this, some of the big pieces that were being sold were pagers, right? So this is predates a lot of the mobile phone stuff. There's a little bit of early analog mobile phone stuff in here, but most of it's actually pager, right? So back in the day, you may not have ever seen a pager. Pager was a little device that you would wear, and when somebody was trying to get a hold of you, they'd call a number, and it would send a message to this thing, and you could look at the pager, and it would tell you what number called, and then you would go to a phone and you would call somebody. And it was a pretty significant. It was one of the first wide use mobile communications products that was available to people. Their pagers were consistently being outpriced by Japanese and overseas competitors, and a big part of it had to do with their costs involved. So Motorola's development of Six Sigma was really an approach and a response to how do we solve these quality issues so that we can be competitive. And in fact, it was so the whole DMAC approach, and that you solve your problems one by one and then go on to the next one, and that the result of what you're looking for. So Six Sigma is essentially no defects. It's 3.14 whatever defects per million. It's essentially no defects, and that's kind of the target that you're reaching for. Now it's interesting. There's different Sigma levels. In the course, I used to have a little audio segment that was actually one of the guys that was at Motorola. Was a founder of Six Sigma, and he was talking about the different Sigma levels of businesses and expectations. And although Six Sigma is certainly world class, that's not where most organizations are, and they don't necessarily have to be there. And you'll find different parts of businesses end up in different spaces. So one of the examples that he gave that he talked about was in the airline business. In the airline business, as far as for the airline operation and the moving you as a passenger from one place to another, they're a Six Sigma business, right? It's safer than most other means of travel. Millions and millions of people move around without there being any injuries or deaths or things like that. However, moving your baggage is probably about a Four Sigma business. And if you travel to any degree, at some point in time, you're going to have your bag show up somewhere other than where you are, either being late or it will get sent to another city, or something will happen like that. And they could do the baggage as a Six Sigma business. Frankly, I don't think customers would spend the money required in order to develop that process to that degree, and that's why they don't have it that way. However, people won't get on an airplane if if there's some likelihood or some reasonable likelihood that they'll actually be injured or killed, right? So the actual moving you around, you definitely need a Six Sigma operation. But moving your baggage, although you don't like the stuff for be late, you don't like it to be lost necessarily, people will tolerate the Four Sigma. And then finally, Lean Six Sigma is basically Lean Six Sigma is a generic version of the Toyota production system. And where it takes from the Six Sigma concepts, right? So you're still DMAC approach, you're still solving your problems one by one. One of the things that you find is once you remove most of the problems that you've adequately controlled for, you start running out of problems to go after, so to speak. So what happens is you focus on waste. And waste in Japanese is muda. And in fact, if you go to Toyota, if you happen to be if you're local to Conestoga today, or in the upcoming terms you're going to be, there's a Toyota production facility in Cambridge, which is within probably about a 10 or 15 minute drive, and they do tours that you can take a tour. It's free. If you're interested, you can contact me offline and I can give you the details of how to get there. But one of the things when they go through and they do it is you hear them talk quite a lot about muda, and muda is waste. So they're always focusing on ways to reduce waste, right? And waste has to do with, using too much materials. Waste has to do with how do you even handle waste materials, right? So one of the things in the plant there is 100% of the waste that's generated in that facility is either recycled, reused, or incinerated, and they capture the energy from the incineration and use it back in the plant. So I'm going to leave it off there today. Thank you for joining, and I'll speak to you next time.